So, looks like it's time for another trying to fix video. Actually, I'm so used to listening to my mate Vince. So this is not another. Was actually my second trying to fix project in recent times, and the first one I shot on video, but I was trying to learn kind of what it's going to look like. Right now the framing's a little off and I need better lighting in here, and so I'm aware of all of those problems. But let me tell you what we've got here, and let me tell you what I've sort of figured out already and show you, and then we're going to get to actually trying to fix it, because I think I know what's wrong and how to get it to work. So what this is let me actually move the meter out of the way. Let me flip this over carefully. This is a Videonics sound effects mixer, ultimately the Boing box. And it's got a keypad here with a series of numbers that you can program in, which, say for instance, 26 is pip and 27 is pop. So, but I can't verify that right now because it's not working. So what I have is I have the power supply, and I'm going to go ahead and plug it in so you can see. Actually, I need to turn it back over and re-secure it slightly. I had it out because I was just verifying a couple of things. And so let me see if I can get this. There's two sort of posts here. Oh, I got to be careful. Now there is, let me see if I can show you. I'm hoping this will come through. There is right here a header, and it plugs into a series of pins on the keypad. So I need to get that lined up rather than smashing it down. So if I line it up properly, I can then plug it in, and the circuit board goes over two posts, and there's a third hole in the middle where I can actually screw down the circuit board to secure it. For now, I'm going to leave it loose that way. I should be able to flip it over, and the power supply plugs in right here. So I want you to watch right here, this ready light here, and I'm going to go ahead, I'm going to get my fingers out from there. It's not high voltage, but still want to be careful. I'm going to plug it in, and I want you to see what happens when I plug it in. Do you see the green light just come on for a second and then go off? So at first I thought, okay, there's a problem with the power supply. That's sort of the typical solution, trying to trace the voltages and what have you. Then it dawned on me there's an on-off button here, and so I'm going to hold that down and just show you that it really doesn't help. I'm holding down the on-off button, I'm letting go, nothing's happening. If I do unplug this, we might see a little blip from that LED. Yep, very, very minor. If I plug it back in, it should do the same thing again. I've got to get it lined up. There we go. And you see, the light comes on and it goes right back off. So I'm going to go ahead and leave it plugged in, turn it over, because what we want to do is we want to look at some of the voltages, and that's why I have the meter here. So I'm going to turn it on. I've already got it set for 20 volts, up to 20 volts. I gotta be careful I don't lose these screws that hold things together. Here's that single screw goes in here, and then I've got two other screws off to the side that are holding the bottom of this thing. So I went and I looked up data sheets. I'm gonna have to try and show you this. Let's see if I can remember. Right about here is a 7805 regulator, and right about there, if I'm remembering this right, is a 7905. Now these are going to be backwards in terms of the pinout because we're looking at the bottom of the board. With the 7805, I went ahead and got a couple of data sheets. I just printed out the first pages of them so I have the pinout. I don't know how well that's going to show, but for the 7805, basically pin 1 is the input, pin 3 is the output, and pin 2 is common. So if I'm going to hook up a voltmeter to it to see what kind of voltage I'm getting, keep in mind this is now, the power supply is now plugged in. So I'm going to put the negative lead on the common. A little trouble aiming there, keeps sliding off. Okay, I'm going to go to pin 1, and actually it looks like I'm getting 0 voltage. Oh, there we go. What do we got? We got 0.89 volts. That's not so encouraging, actually. Let's look at the output. Gotta be careful I don't bridge these together and short something out. So let me switch hands here. And for those that don't know, my right hand is a little bit messed up. So if you see me shivering or, moving my hands around a lot. Okay, now we got 0.14. Those voltages are way too low. So there's something suspicious about the 7805. The 7905, which is supposed to be a negative 5 volt regulator, is laid out differently. Pin 1 is the ground, pin 2 is the input, and pin 3 is the output. And I'll leave that there for a second, but ultimately you can go look it up online. Just Google 7905. You don't even have to say much else, just 7905 and go to the images and you'll find a pinout. So the ground is on the first pin, the input is on the second, and the output's on the third. So if I'm doing this right, and that's the 7905, this is the ground pin. Let me go straight to the output first. And here I'm getting 5, well, it's hard to get a good connection here. I'm getting 0 volts right now. Oh, that's okay. That should be ground. Let's go to the middle pin. Okay, there we go. Negative 5 volts right there. That's interesting. Why am I getting... Oh, I look like an idiot, don't I? All right. Let's be sure what we're dealing with here. Basically what I did was I went out and I got both regulators and some thermal grease. So I'm going to go ahead and unplug this now. I'm going to get the board off, you want to carefully pry up where that header is, because you don't want to bend those pins. If you can get it pried up, then you can back it out, and I'm just folding it over at the ribbon cable here. And so what I've got, okay, it looks like I got it backwards. That's why my numbers weren't making a whole lot of sense. But what I can do, bring the power supply over here. Let's do this right side up. Now you saw that light just blinked on for a second, but now I've got live voltage in here. Keep in mind, this is a power supply that's already stepped it down to 12 volts. So really what the regulators are doing is taking that 12 and making smaller voltages. So if it needs 12 volts, it's already got it from here. If it needs 5 volts or negative 5 volts, it's getting it from these two regulators. So the 7805 is on the left and the 7905 is on the right. So the 7805 had the ground pin in the middle, or the common pin. So let's go ahead and test for voltage there. Let me move this over a little bit. I want to be careful not to bridge things. Don't want to short it out. All right, I'm going to shoot for input should be on pin 1. And there, it's getting 10. I lost my connection. It's getting 10.43 volts. Output should then be 5 volts. 4.97 volts. So the 7805 actually looks like it's okay. The 7905, I'm going to switch hands. The ground pin was the first pin, and the input was on the second pin. I've already got negative 5 volts there. The output is 4.1 volts. if I'm reading that right. Now that's curious. Why do I have negative 5 volts going in and less than that coming out? Let's double check the data sheet. For the 79, so ground and input. Okay, so ground is pin 1. And input is 4.97 volts. Basically, it almost looks like it's taking the 4.97 off of the 7805 over to the 7905, but the output doesn't seem right. Because it's actually coming up less. That's interesting. Okay, well, I'm going to think about that and come back. Okay, it's taken me a little while to get back to my original conclusion here. Let me see if I can sort of explain. There is, I've retraced, essentially you've got the power coming in here, goes through bridge rectifier to re-rectify. It's already a DC voltage coming in, but that does a couple of things in terms of engineering. It's a bit more protected that way. And then it goes through, I believe it's going through this capacitor here as a filter capacitor. So it's really straightening out that 12 volts, although what's actually coming through is like 11.9 volts. Okay. Now, that said, the input going into the 7805, if I measure, and you want to look here, let's see, I don't even know if that's got enough light on it. Well, let's fix that. There we go. That should make it a little bit more visible, I hope, without blowing it out completely. Let's see. There we go. That should be better. So now, the middle pin on the 7805 is the ground, so I'm going to take that. And the first pin is the input. Now, when I look at the input here, I'm actually getting 10.3 volts, but that actually makes sense because you've got 11.9 coming in, and you're going through 2 diodes, which is about a 0.6 volt drop across each. So 1.2 volts down from 11.9 would actually take you down to 10.7, but let's just say there's other losses in there. So ultimately the 12 volts is being sacrificed here. As long as it stays above 5 volts, then the 5 volt regulator should be able to give you 5 volts. So that said, now I'm going to go to the output pin on the 7805, and I'm getting 4.9 volts. This could also be that my meter is off by 1/10 of a volt. It's a cheap meter, but I'm in the ballpark, so I'm happy with that. Now, on the 7905, I'm going to put the ground lead on the common pin, the ground pin. Now, it's actually not common, and I'll explain that in a second. But if I go to pin 2, what's actually happening is the 5 volts is being carried over in reverse, and there's my 4.9 volts, except it's negative. So it's negative 4.9 going in, and unfortunately it's dropping to 4 volts, negative 4 volts, or negative 4.1 coming out, which is lower than what the regulator should be giving me. So the 7905 is suspect. So I'm going to go ahead and replace that. While I was at it getting the 7905, I went ahead and got a 7805. I figure these are both aged. So if I'm going to replace one, I might as well replace both. So ultimately the next step here, after unplugging the power, is going to be to plug in my soldering iron and attempt to desolder these, and we'll start getting the new components in, and we'll see if this fixes the problem. Okay, the iron is now heated up, and the first thing I'm going to do is go ahead and flow some fresh solder onto these components. Now these are actually sort of heat sinked, so it may be hard to melt the solder. Boy, that's a lot of smoke for not a lot of work. see if we can't. Come on, there we go. Oh, we got more than we asked for, but we'll suck it all off. And all right, that's not pretty, and it's not close up, but this is my first video doing this. I'll eventually get all the equipment together. So I got my handy dandy solder sucker, which is I love, and I can't tell how much that did or didn't do. Okay folks, so it's taken me at least a half hour to do this. I'll put a number up, but there we go. There's the board. Let me see, maybe I can turn this light in such a way that it shines. Well, hopefully you can see that the holes are clear, the devices are off. There are things that I'm still learning. With all my sort of experience, my training and everything else, actually sitting down and messing with the circuit board can be tough if you don't have a bunch of experience. But now I got them cleared out, I'm going to put the new devices on. Okay, so now the two devices are mounted. You want to take a wild guess what the next step is? Actually, look at it, I forgot to snip off the excess leads on the back of the 7905, so we get that handled. But I want to clean up the back of the board, and to do that I'm going to use isopropyl alcohol, or what. What's also important is where the voltage regulators here, I use my pointer, the voltage regulators here were actually mounted to the board, and there was a little bit of thermal grease, if you will. There are different names for it, but basically I think thermal compound is more proper. And what that does is allow the transfer of heat. Now this is not a true heat sink. What they've done is when they made the circuit board, yeah, there's a fair amount on there. When they made the circuit board, they left the solder mask off part of it so that there was a conductive surface, and so they're ultimately conducting the heat from the voltage regulator down into the circuit board, and that's part of the reason I think why the circuit board is covered in it's basically all a copper coating in there, and they didn't etch it away. They only etched away the minimum that they needed to be able to fit all the traces for all the different components, but then left a giant like ground shield here. And they also used, I don't know how visible that's going to be, these plastic thingies. I don't know. Let me see if I can get it up closer to the camera. These plastic things. There we go. That had the thermal grease on them. I'm going to ignore the plastic. I think the idea is to conduct the heat into the board. Perhaps the plastic was there as an insulator, now that I think of it. But there should have been two of them, and I only had one fall off while I was working. So I'll see what I can do. Maybe I can put that one plastic piece back and look around and see if I find another one. Alright, so there's a plastic piece. There should be another one around here somewhere. Should have come off when I took the other off, or when I took, no, not that. This appears to have protection circuitry. The soldering iron is off. Let's get rid of these. as things fall. Clive would call it an avalanche. All right. Let's see now if I plug it in. Oh, the light didn't stay on. Maybe we have a different problem. Or maybe it's the fact that it's not connected to everything else. Yeah, we got the same little blip of light. Let's get the rest of this hooked up. I know I still need to go back in and get that 1 voltage regulator, but I want to get all the circuitry connected up so we can see what happens now when we plug in. Boy, I need a bigger workbench. All this. All right. Cross your fingers. Now, came on briefly, but let's see now. If I hold on the on button. So I'm guessing that means it's another component that's dead. So this is a fail. I'm going to go ahead and clean the rest of it up, and unless it miraculously comes back to life, or if I could find a manual that tells me how all this is supposed to work, I'll come back and I'll finish up. But for now, thanks for watching. Wait a minute, did you think I was going to leave you hanging like that? It's not just a fail. We've got to do a little bit more evaluation because we were checking the voltages before and we knew something was off. So let's go ahead and check the voltages again after I pick up the voltmeter that I dropped. It's still alive. Not built like a tank, but it's still alive. All right. Switch this over to volts. I think there's stuff in the way. It's the light that's in the way. All right. So we should be getting, when we're plugged in, we got the green light. If I remember these regulators correctly, common's in the middle, and the input coming up at 3 volts, and the output, wow, how do I have less voltage? It's not sitting on top, it's not shorting out there, is it? Let's try that again. 3 volts coming in. That doesn't make any sense. All right, let's try common here. -6, -5. Okay, so now the negative regulator is working, but the positive isn't. So why do we have 3 volts coming in? All right, let's flip her over again while still plugged in and make sure we still got 12 volts coming in. .75. Okay. All right. Well, I am going to do a little more diagnosing, and I'll get back to you eventually. Maybe part 2 of this video. We'll see how it goes.